Hi everyone, welcome to AI Crack channel. This is Akash Gangwar and today we'll be studying straight lines lecture 6. So this is the last lecture of straight lines and we'll be studying few application based concepts in this particular lecture. We won't be deriving any of these formulas, but we will be remembering them because more or less all of them are derived from the similar form of line, that is parametric form of line, right? So let's start with distance of a point from a line. So let's say this point is called as A with coordinates x1, y1, and let's say this is line ax plus by plus c equals to 0. Now we have to find out the distance of a point from the line. When we are talking about distance, we are actually meaning perpendicular distance. So this is the perpendicular drop on this line from this point. Let's say this distance comes out to be d. So according to our derivation or the formula, we'll be getting d equals to modulus of ax1 plus by1 plus c divided by under root of a square plus b square. Basically, we have to plug in this point into this equation, write in the numerator, divide by under root of a square plus b square. That is the coefficient of this particular line. So coefficient of x whole square plus coefficient of y whole square, and take the under root and take the modulus. So this is how the formula looks like. Okay. Now let us talk about distance between two parallel lines. So we have been given over here ax plus by plus c1 as the line 1, and this is line 2 with c2 as the constant. We know that coefficients of x and y in case of parallel lines are same. So here ax plus by, only difference is the constant term. Over here it's c1, over here it's c2. So the formula is quite simple. That is modulus of c1 minus c2 divided by root of a square plus b square. So that also comes with the help of parametric form. So you have to remember this formula as well. Now let's talk about foot of perpendicular from a point on a line. So let's say this point is again A with coordinates x1 and y1, and this is the line ax plus by plus c. Now we found out the distance d, but we don't really know what are the coordinates of this point x and y. Let's call them x and y, and this is x1 and y1. So the way these are defined is x minus x1 divided by coefficient of x, that is equals to y minus y1 divided by coefficient of y, that is b, and that is equals to minus times ax1 plus by1 plus c divided by a square plus b square. Again, you can see the similarity between the formula of distance, perpendicular distance from point A to this line and this particular formula, right? So all of them are derived from the parametric form only. So basically, how do we have to solve this one? We have to write x minus x1 divided by a equals to minus times ax1 plus by1 plus c divided by a square plus b square. We have to solve this equation first, and then we have to solve y minus y1 divided by b equals to minus times ax1 plus by1 plus c divided by a square plus b square. Then we have to solve this one, and this way you'll get the coordinates of x and y, basically coordinates of this particular point. So you'll get the x and y value. Okay. Now let us talk about image of a point with respect to line, and this particular concept is more or less similar to the previous one which we have studied. That is image foot of perpendicular from a point on a line. That is more or less similar to this one only. So let's say this point is A with coordinates x1 and y1, and this is the perpendicular drop D with a distance D. Now when we are talking about the image, we know that the property of image formation, image would be formed over here, like let's say this is x dash and y dash, and that would be d distance away from the mirror. If this is the mirror, then if this is d distance, then this would also be d distance, right, because of the properties of the image. So if we could find out the points of this particular point, then we can also find out the points of this particular point. Only difference is over here distance was d and over here distance was 2d. So the formula comes out to be x minus x1 divided by a equals to minus 2 times ax1 plus by1 plus c divided by a square plus b square. Similarly, y minus y1 by b equals to minus 2 times ax1 plus by1 plus c divided by a square plus b square. Both the formulas, these two formulas and this particular formula are more or less same. The only difference is 2 over here, because over here it was just distance d, over here it's distance 2d. So that is why minus 2 over here and just minus 1 over here. Okay. So if you have remembered this formula, then you will probably remember this formula as well. Now let's try to solve few examples. So this example says an equilateral triangle has base along the line 12x plus 5y plus 11 equals to 0, and one of the vertex is 1 comma minus 2. Find the area of triangle. Let's say this is our vertex 1 comma minus 2, and let's say this point is A, and this is our triangle A, B, and C. So equation of BC is given as 12x plus 5y plus 11 equals to 0. Now we are dropping one perpendicular, and this distance is, let's say, D, and the distance AC is, let's say, A. We know the formula that D equals to A times cos theta, where this is theta, and this theta equals to 30 degree only, right? So basically D equals to A cos 30. So this means A equals to D by cos 30, D by cos 30, right? Now we can find out the value of D with the help of formula. So that would be D equals to modulus of AX1, that would be 12 times x1 would be 1, 12 into 1 plus by1, b over here is 5, y1 is minus 2 plus c, that is 11, divided by under root a square plus b square. A over here is 12 and b over here is 5, so that would give me under root 12 square plus 5 square, so that is 144 plus 25, that is 169. So that would eventually become 13 square is 169, right? Now this is minus 10 and this is 12, so this becomes 2. 2 plus 11 is 13. 13 by 13 equals to 1. So distance comes out to be 1. So if distance comes out to be 1, then A equals to 1 by, that is root 3 by 2. That becomes 2 by root 3. Now with formula root 3 A square by 4, you can find out the area of this particular equilateral triangle, right? Now let's look at this example. Find all the points x plus y equals to 4 that lie at a unit distance from the line 4x plus 3y minus n equals to 0. So let's say this is our line 4x plus 3y minus 10 equals to 0, and this line is cutting like this, x plus y minus 4 equals to 0. Now I'm not drawing the exact lines by taking out the slopes on coordinate axis, because that doesn't really matter, because we have to solve eventually mathematically in such questions. So let's say this point is A, and we are dropping one perpendicular, this unit distance is 1, and let's say this particular point is B, and we are dropping one distance over here. Okay, now you can see that we'll be getting two answers, one of this point and one of this point. So in our formula we actually have the modulus of something, that would be 1. So we'll be solving one time with plus sign and one time with negative sign, and we'll be getting 2 points. Okay, so let's take the variable coordinates. So let's say this point is x1, then other point would be 4 minus x1, right? Because y equals to 4 minus x. So if this point is x1, the other point would be 4 minus x1. Now let's try to write the formula. So 1 equals to modulus of ax1, that would be 4 times x1 plus by1, that would be 3 times 4 minus x1 minus 10 divided by root 4 square plus 3 square, that would be 5 only, and that is equals to 1. Now let's try to solve it with plus sign first. So 1 equals to 4x1, and we will be getting minus 3x1, so that would be x1 plus 12 minus 10, so that is 2. So x1 plus 2 divided by 5 equals to 1. That would give me x1 plus 2 equals to 5, that is x1 equals to 3. So that is our first point. Now in case of second point, we'll be solving with minus sign. So minus 1 equals to x1 plus 2 divided by 5. So that would give me x1 plus 2 equals to minus 5, x1 equals to minus 7. So 1 point would be x1 equals to 3, and similarly we'll be getting y coordinate as 4 minus 3, that would be 1. So 3 comma 1 is 1 point, and the other point would be 4 minus 7, that would be minus 7 comma 11. So these are the 2 points which we'll be getting. Now let's look at this example. In triangle ABC, A1 comma minus 2, perpendicular bisectors of AB and AC are these and this, and equation of BC, we have to find out the equation of BC. So let's say this is our triangle A, B, and C, and these are the perpendicular bisectors, right? Now this point is being given as 1 comma minus 2, and let's say this point is xb yb, and this point is xc yc. Okay, now we have to find out the equation of BC. Now since this is the perpendicular bisector, so this distance and this distance is equal, this distance and this distance is also equal, right? So basically we can use the concept of image. So the equation of this line is given, that is x minus y plus 5 equals to 0, And similarly for this one, x plus 2y equals to 0. Equation of both the perpendicular bisectors are given. So we can find out the image of A with respect to this line, and thus we can find out the coordinates of point B and point C, and after that we can find out the equation of BC. So let's try to solve the first part, basically the coordinates of B. So that would be xb minus x1 over here is 1, divided by a over here is 1, and that is equals to minus 2 times ax1 would be 1 times 1 into 1, plus by1, b is minus 1 over here, and y1 would be minus 2, plus c, that is 5, divide by a square plus b square. A square plus b square would be 2, minus 2 times this. Okay, so this is 5. So this comes out to be, this constant comes out to be 1 plus 2 plus 5. So basically 8, and this 2 gets cancelled out. So we'll be getting minus 8. xb minus 1 by 1 equals to minus 8. So basically we'll be getting xb equals to, this would become minus 8, and this is plus 1 over here, so that is minus 7. So similarly we'll be getting yb. So y minus y1, so yb minus, and that would be plus 2, divide by b, sorry, that would be minus 1, and that is also equals to minus 8 because this constant remains the same. So yb equals to this becomes plus 8, and this becomes minus 2 over here, so that is 6. So the first coordinate we have got is minus 7 comma 6. Okay, now let's look at the second one. So for that I'll draw the diagram over here. So this point is 1 comma minus 2. This line is x plus 2y equals to 0, and we have to find out the point C, xc and yc. Okay, now x minus x1, that would be xc minus 1 divided by a, that is 1, and that is equals to minus 2 times ax1, that would be 1 into 1, plus b times y1, that would be minus 4, right, and plus c, that is 0, divide by a square plus b square, that would be 5. So that comes out to be minus 2 times, that is 3, minus 3. So this cancels out. So basically it becomes 6 by 5. So xc equals to equals to 6 by 5 plus 1. So that would be 11 by 5. Similarly, yc plus 2 divided by b, that is 2, and that is equals to 6 by 5. So that would give me this, this goes over there, that becomes 12 by 5, and yc equals to 12 by 5 minus 2, that becomes 2 by 5, right? And now since you have got the coordinates of b and c, you can basically use the 2-point form to find out the equation of bc, right? So this is how you have to do it. Now let us talk about family of lines. Any line passing through the point of intersection of lines L1 and L2 can be written as a1x plus b1y plus c1 plus lambda times a2x plus b2y plus c2 equals to 0. This is just c2. Okay, so how can we say that if these two lines are there, then the third line can be written as this one, and that would also pass through the point of intersection of these two lines. So let's see how it goes. Let's say these are the two lines. This is L1, this is L2. So let's say this is a1x plus b1y plus c1 equals to 0, and let's say this is a2x plus b2y plus c2 equals to 0. Now let's say the point of intersection would be x1 and y1. So we know that a1 x1 plus b1 y1 plus c1 equals to 0, and similarly a2 x1 plus b2 y1 plus c2 equals to 0, because this point is lying on both L1 and L2, right? Now let's say I'm writing L3 as a1x plus b1y plus c1 plus lambda times a2x plus b2y plus c2 equals to 0. Now if I plug this value in this line, we'll be getting a1x1 plus b1y1 plus c1 plus lambda times a2x1 plus b2y1 plus c2, right? And yes, so basically this value is also 0 because of this, and this value is also 0 because of this. So basically this is also 0. It's not 0 over here, and this is 0 over here, right? So with this we can say that this particular point is also satisfying this equation, and that means that this line L3 also passing through the point of intersection of both L1 and L2, right? So this is how we have to solve questions of family of lines. So let's see with the help of an example. Find the equation of straight line which passes through the point 2 comma minus 3 and the point of intersection of the lines x plus y plus 4 equals to 0 and 3x minus y minus 8. So initially what we used to do, we used to solve these two lines, find the point, and then use 2-point form to find out the equation of the line, right? But now we'll be doing something else. So I'll be writing L3 as x plus y plus 4 plus lambda times 3x minus y minus 8 and equals to 0. So this is our L3 line, and now this point is satisfying in this line. So basically that would mean 2 minus 3 plus 4 plus lambda times 3 into 2, that is 6, minus of minus 3, that would be 3, and minus 8. So 6 plus 3 is 9 and minus 8, so that is nothing but 1, and this one is 2 minus 3. So basically this is minus 1 and plus 4, that is 3. 3 plus lambda equals to 0. So basically that gives me lambda equals to minus 3. Now you have to just plug this value over here to find out the equation of L3, and that is how we have to use family of lines to solve this question. Earlier we used to solve these two equations, find out the point, and then use 2 points to find out the equation of line, but over here we can do this in a simpler manner. Now let's look at one more example. Obtain the equation of lines passing through the intersection of lines 4x minus 3y minus 1 equals to 0 and 2x minus y plus 5 plus 3 equals to 0 and equally inclined to the axis. So when I'm saying equally inclined to the axis, that means it can be either this or this. Basically this theta, this is theta, this is phi, this is phi, and similarly it can happen over here as well. Let's say this is gamma and this is also gamma, similarly over here as well. So basically it actually means that this angle is 45, not theta or gamma. This angle is 45 because it is equally inclined and this is right angle. So that means m can be either 1 or m can be minus 1. Minus 1 can be, in this case, m equals to minus 1, and in this case m equals to 1. So both are possible. So we have to take two cases over here. So let's say the line is, because line is passing through the intersection of these two lines, so we can write with the help of family of lines 4x minus 3y minus 1 plus lambda times 2x minus 5y plus 3 equals to 0. So this is our line L3, and we'll take the x terms together, y terms together, and see what happens. So that would give me x times 4 plus 2 lambda plus y times minus 3 and minus 5 lambda plus 3 lambda equals to 0, right? Now either m equals to 1 or m equals to minus 1. Let's take the m equals to 1 case. So m with this equation minus times coefficient of x, that would be 4 plus 2 lambda divided by coefficient of y, that would be minus times 3 plus 5 lambda, and that is equals to either 1 or minus 1. So let's take the one case first. That would give me 4 plus 2 lambda equals to 3 plus 5 lambda. That would give me 3 lambda equals to 1, lambda equals to 1 by 3. And for the other case, that would give me 4 plus 2 lambda equals to minus 3 minus 5 lambda. That would give me 7 lambda equals to minus 7, lambda equals to minus 1. So for these two lambda values, we can find out the L2 values of two L3 equations. Okay. Now let's look at one more example. If 2a minus 3b plus 6c equals to 0, the family of straight lines ax plus by plus c equals to 0 passes through a fixed point. Find the coordinates of the fixed point. So when I'm trying to find the coordinates of fixed point, I see the equation in terms of family of lines in the format ax plus by plus c, a1x plus b1y plus c1 plus lambda times a2x plus b2y plus c2, and then I solve this and this equation to find out the point of intersection of the family of lines, right? But we are not given over here in such a format. This equation is given a plain format, so we have to find out, we have to basically convert this simpler format into that kind of format. Okay, so how do we do that? So we have given one more information over here. So what I'll do, I'll substitute value of a over here. So a equals to 3b minus 6c by 2. So basically that is 3b by 2 minus 3c. Okay, so I'll plug that value in this equation. That would give me 3b by 2 minus 3c times x plus by plus c equals to 0. Now what I'll try to do, I'll take the b value together, a value together, not a, b and c value together. So for b, I'll be getting b times 3 by 2 x plus 1 plus y, sorry, not 1, since b is over here and b is over here. And similarly plus c times 1 from here, 1 minus 3x. This is equals to 0. Now if I divide this entire equation by b, then that would become c by b, and I can call c by b equals to lambda, right? So that becomes 3 by 2x plus y plus lambda times 1 minus 3x equals to 0. So basically that gives me x equals to 1 by 3. And also if I plug in this value over here, 1 by 3, I'll be getting y equals to minus 1 by 2. So these are the points from which this family of line is passing. So with this, we have completed the syllabus of straight lines, and from tomorrow onwards, we'll be starting with circles. So let's meet tomorrow. Thanks for watching.